So today we shall discuss about the new chapter which is called as work, power and energy. Work, energy and power, whatever it may be. So let us discuss about this chapter here. So first of all, you should know that work done is nothing but force into displacement. Okay. This is a basic formula, a simple formula here. Work done is equal to force into displacement. Okay. So my dear students, let us discuss about the work done in different angles here. Components, by using components here. Let me discuss about that. So you all know that, let us take one trolley is there. And let us imagine this is going to be a road on which there is a small speed breaker. यहाँ trolley है. This is a trolley where this trolley has been pulled by a boy. This trolley is pulled in this direction. Okay. And what is going to happen? In this direction, one component is acting here. Okay. Now just here, क्या हो रहा है यहाँ पर? What is going to happen? Let us see. Now this is going to be the force F. A force is acting on the trolley. और वो जो force काम कर रहा है ना, it is making certain angle. How much? This is going to be an angle theta here. Okay. Now this is force F. It is making angle theta with the horizontal. तो यहाँ पर जो है ना ट्रॉली को जो फोर्स खींच रहा, कौन सा फोर्स खींच रहा है यहाँ पर? ये वाला फोर्स. इवन डिस्प्लेसमेंट भी वही डायरेक्शन में काम करेगा. ओके, व्हाट इज गोइंग टू हैपन नाउ? डिस्प्लेसमेंट इज आल्सो एक्टिंग इन द सेम डायरेक्शन. ओके, सो डिस्प्लेसमेंट इज आल्सो एक्टिंग इन द सेम डायरेक्शन. सो हियर एफ का कंपोनेंट एफ cos थीटा. सो यहाँ पर जो है ना, कोई भी ट्रॉली को अगर कुछ एंगल से हम खींच रहे हैं तो एफ काम नहीं करेगा. उसको आगे बढ़ाने के लिए अलोंग द डायरेक्शन ऑफ द रोड एफ cos थीटा काम करेगा एंड इट इज गोइंग टू टेक अ डिस्प्लेसमेंट इन दैट डायरेक्शन. तो यहाँ पर what is the in which force is also in the same direction and displacement is also in the same, which is nothing but F dot S. Okay, force is a vector, displacement is also a vector. ठीक है, force is a vector, displacement is also a vector. तो ये होगा हमारा वर्क. जब कभी भी स्पीड ब्रेकर आ रहा तो बॉडी को थोड़ा ऊपर लिफ्ट करने के लिए कौन सा कंपोनेंट काम करेगा यहाँ पर? F sin थीटा. Okay, so F sin theta is called as lifting force. It is called as lifting force. Okay, and F sin theta is called as lifting force, and F cos theta क्या है ये? This is called as pulling force. A dot B is nothing but mod A mod B cos theta. तो ये जो है ना डॉट प्रोडक्ट के लिए the best example for dot product is force into displacement are vectors and the product is a scalar. Work is a scalar. इसलिए इसको क्या बोलते हैं? डॉट प्रोडक्ट भी बोल सकते हैं और इसको और एक भी नाम है इसके अंदर. इसको it can also be called as scalar product having certain components here. Next, see here, next thing is work done is positive. Okay, work done positive कब बनेगा, negative कब बनेगा, we shall discuss here. Let us take a steps here. Okay, let us take certain steps here. A man is taking a suitcase and moving. In which direction is moving? He is moving in this direction. Okay, so displacement is in this direction, whereas force is acting in the upward direction. Force is in the upward direction, displacement in this direction. What is this? This is called as angle theta. Okay, so work done is called as positive when theta is less than 90 degrees. Okay, when theta is less than 90 degrees, according to the concept of trigonometry, this is 0, this is 90 degrees, this is 180 degrees, this is 270 degrees, and this is 360 degrees. Okay, so क्या होगा अभी यहाँ पर? This is all means all are positive here. Sin, cos, tan are going to be positive here. Silver means only sin is going to be positive here. Okay, and T means tan is going to be positive. Cups means only cos is going to be positive here. Okay, so all silver, T, cups. Okay, when theta is going to be less than 90 degrees, it is coming under the first quadrant. क्या बोलते हैं इसको? First quadrant बोलते हैं. It is called as a first quadrant, and this is called as a second quadrant. This is called as a third quadrant, and this is called as a fourth quadrant. You all know about that. तो अगर theta less than 90 अगर हो गया, this is this is going to be 90 degrees. Okay, if it is less than 90, cos is going to be positive. Okay, cos is going to be positive. इसका मतलब क्या? When the work done is said to be positive, which is Fs cos theta is going to be positive here. Why positive? Because cos value, if it is less than 90, it is showing positive here. If it is greater than 90, it is showing negative here. Okay, so work done is said to be, work done by man is positive. Okay, so next thing is when the work done is taken as negative. यहाँ पर work done negative कैसा है? Work done is negative. Okay, now just see here on this suitcase, man is applying the force upward direction, but gravity is acting in the downward direction. Gravity कहाँ पर काम करेगा? नीचे की तरफ काम करेगा. If gravity is acting downwards, then what is the work done by the gravitational force? This is theta, which is greater than 90 degrees. This is less than 90 degrees. Okay, so work done by man is positive. Work done by man is positive because man and displacement they are less than 90 degrees. So work done by man is positive. Next here, work done by gravitational force is Fs cos theta, which is going to be negative. Why? Because theta is greater than 90. ये angle जो है greater than 90 है यहाँ पर. Theta is less than 90 degrees here. Is it okay? तो ये हो गया displacement, ये हो गया force, ये हो गया force due to gravity. So Fs cos theta, which is taken as negative here. Okay. So this is about the concept of positive work. So let us say this is a road and this is a suitcase. Now just here, a man is holding a suitcase here. Okay, a man is holding a suitcase and walking on the road. He's walking on the road. Then what is happening? How many forces are acting on the man? He is having a displacement in this direction, and he's having force due to man is in the upward direction. Force due to gravity is in the downward direction. और ये जो एंगल बनाएगा 90 डिग्रीज बनाएगा. So work done by man is going to be Fs cos 90, which is taken as 0. Work done by gravity. See, man will pull the body upwards. Gravity is acting downwards. So force due to force of the man, force due to gravity, displacement, and it is also going to be cos 90. Why? So when the work done is said to be 0, when the angle between the force and displacement is taken as 90 degrees, so cos 90 क्या हो रहा है यहाँ पर 0. As cos 90 is going to be 0, work done is going to be 0. Okay. So one more example we can give for this. For example, I am taking one stone, okay, and a rope is tied to the stone, and the stone is rotated like this, okay. Stone is rotated in a circular motion. Then what is the work done by a man? So you are taking one finger here. Let us imagine this is a finger, and you are tying the rope to your finger and rotating the stone like this. So क्या हो रहा है यहाँ पर? This is taken as displacement, and in this direction there is a tension, and what is an angle here? 90 degrees. So work done by tension on the stone is Fs cos 90 degrees. So work done by tension is also going to be 0. See here, एक stone को अगर से टाई कर दिए रोप से और उसको गोल घुमाना शुरू कर दिए, तो what is the work done by your finger is going to be 0. और यहाँ पर जो है ना एक हमाली एक इस to be कूली जो है जो भी लेबर काम कर रहा, okay, he will take your suitcase on his head, 3-4 suitcase सर पे रख के रोड पे चलेगा. According to the rules of physics, the work done by him is 0. Okay, why? Because I told you just now. A man holding a suitcase on his head is moving in this direction. Displacement है, force upward direction. तो वो जो है ना आपको 2-4 किलोमीटर ऊपर सर पे रख के जो है तुम्हारे उसका physically has done lot of work, but according to physics rules, work done is going to be 0. So that is the concept here. तो अभी work के बारे में समझ में आ गया. Then we will go for an application here. What is an application? There is a pendulum hanging. Okay. So what is the mass of a pendulum? Let us say mass of the pendulum is taken as m. You are lifting a pendulum to a side. तो ये pendulum को जो है ना इसको थोड़ा बाजू में उठा दिए against to the gravitational field force. So what is the height you have lifted? कितना height तक उसको lift? But what is the total length of the pendulum? It is L. Just I told you it is L. Okay. So what is the work done by you? Work done by gravity. See, gravity is pulling downwards, but you are taking it against to the gravitational force. That will become negative work. Okay. Work done by gravity will become negative. Why you are taking the pendulum bob against to the gravitational force? It is going upwards, it is negative. It is coming downwards, it is taken as positive. Okay. So work done is going to be how much? It can be considered as mg into h. Okay. mg into h. Because this mass you are lifting up to here, mg into h. No. So work done by gravity is considered as mg into h. So h क्या है यहाँ पर? h मालूम करने के लिए क्या करेगा? You have to consider L and subtract this L cos theta from that. For example, you are lifting this body up to 60 degrees. Then what is the work done by you? You should consider a negative sign here. क्यों negative लेना है? Because you are taking against to the gravitational force. Then what is this going to be? mgl 1 minus cos 60. Okay, so it's going to be minus mgl by 2 because 1 minus 1 by 2 cos 60 is 1 by 2. So this is going to be your gravitational force. अगर वो दे दिया mass of a body is taken as 1 kg, then what is your gravitational? What is the work done by gravity? Minus 1 into 10. अगर length of a pendulum आके 1 meter है, so you'll be getting 1 meter divided by 2. So it's going to be minus 5 joules. Okay, तो आपका आंसर क्या है? So pendulum का केस तो हम समझा दिए. What is the work done by you when you lift the pendulum? But it is not a pendulum, it is a rod. Okay, work done on the rod now. This is a rod having length L. The total length of the rod is L. Okay, and what is the half of the length? It is taken as L by 2. जो यहाँ से यहाँ तक का length है L by 2 ले रहे हैं. See, whenever you take a uniformly distributed body, अगर rod के ऐसा body अगर ले रहे हैं, तो you have to consider center of mass. Okay, so this is the center of mass. When you lift the body upwards, you have to consider only this much height. Okay, you will consider only this much height. Understood? ये L by 2 हो गया, तो ये हो गया L by 2 cos theta. ठीक है? Then what is the work done by gravitational force? Work done is equal to minus mg. क्यों लेना minus? Because you are lifting a rod against to the gravitational force. A simple difference between the pendulum and the rod is यहाँ पर pendulum के पास हम total length of the rope लेंगे और rod के पास only half of the length of the rod लेंगे. As simple as that. Now what is the h here? The h मालूम करना है from here to here. This is called as center of mass. So total length L by 2 है, h मालूम करना है. So h is nothing but L by 2 अगर common कर दिया, it is going to become 1 minus cos theta. So what is the work done against the gravitational force means minus mg h. h के प्लेस में क्या लेंगे? L by 2 into 1 minus cos theta. पेंडुलम का फॉर्मूला है यहाँ पर, बट पेंडुलम के अंदर so this is going to be our formula. Understood? The final formula is for a rod. Next, this is a chain. Some part of a chain is hanging. Okay. So क्या हो रहा है यहाँ पर? some part of a chain is hanging here. तो कितना chain hang कर रहा है यहाँ पर? Let us imagine L by nth part of a chain is hanging. Okay, L by nth part of a chain is hanging. You are applying certain force. यहाँ पर हम force apply करके पूरे के पूरे chain को जो है ना टेबल पे लाने की कोशिश कर रहे हैं. पूरे chain. Okay, so what is the mass of the hanging chain? We can consider this as m by n. Okay, m by n. Why m by? What is this m by n? Mass of the hanging chain. What is this L by n? This is said to be length of the hanging chain. मगर जब कभी भी हम length of the hanging chain लेंगे तो क्या लेंगे यहाँ पर? You have to consider height of the hanging chain as जितना भी हम length ले रहे हैं यहाँ पर, because this is a uniformly distributed body, हम क्या करेंगे? L by n divided by 2 लेंगे. क्यों? Because we are taking center of mass. Center of mass लेंगे यहाँ पर. जितना भी हम length ले रहे हैं यहाँ पर, because this is a because L by n is hanging, we will take only center of mass part, that much only. That much part only we take. This much part only we will take. So uniformly distributed body जब भी आएगा ना, we will take only center of mass part. So work done in pulling the chain. So what is the work done by you in pulling the chain here? Okay. तो क्या हो रहा है यहाँ पर? Work done in pulling the chain is mass of the hanging chain into G and height of the hanging chain. Because work done is mgh. So work done to pull a body is taken as mass of the hanging chain कितना है? M by n. G. Height of the hanging chain कितना है? L by 2n. That's it. So therefore, we write work done to pull the chain is taken as mgl by 2n square. So ये हो गया आपका formula. Work done to pull the chain completely on the surface is mgl by 2n square. And you can take minus because you are pulling the body against a gravitational force. Minus भी ले सकते हैं इसको. Okay. Now see work done by lifting force and what is the work done by gravitational force on both the cases. So work done by lifting force बोलते हैं इसको, it is lifting force. FL बोल के बोलते हैं. This is a gravitational force. If G is acting downwards, FL is acting upwards. This is taken as displacement from top to bottom. So work done. What is the formula for work done यहाँ पर? कितना formula क्या formula आएगा यहाँ पर? So work done by the lifting force is taken as force of the lifting force into displacement. So work done by lifting force is nothing but force on the lifting force. कितना है यहाँ पर? You consider this as m into g. Okay, both the cases. So force done by lifting force is on the mg only, and this is also on mg only because F is equal to ma according to Newton's second law, and acceleration will become acceleration due to gravity. So in both the cases we will consider mg and mg. So force due to lifting force and force due to कितना है यहाँ पर? mg, and displacement क्या है यहाँ पर? height, and this is taken as positive. क्यों positive? You can just see here lifting force भी ऊपर की तरफ है, डिस्प्लेसमेंट भी ऊपर की तरफ ही है, तो एंगल क्या हो गया? 0 डिग्रीज. सो हियर थीटा इज इक्वल टू 0 डिग्रीज. ओके, मगर यहां पर देख लो, when you lift a body, gravity is acting downwards, displacement is upwards. So work done by gravitational force is taken as minus mgh. क्यों minus mgh? Because gravity is acting downwards, lift is acting upwards, theta will become 180 degrees. Okay, 180 degrees means negative. Theta is greater than 90 because negative work done here. This is positive work done. Okay, this is negative work done. Hope you are understanding what I am telling. Next, you can just see work done by a man who is standing. This is a well. Okay, this is a well in which water is present, and there is a bucket, and a man is lifting the water from the bucket. Okay, so length of the rope is given as L. Mass of the rope is m. Mass of the bucket is capital M. Okay, so what is the work done by him? So work done is nothing but work done on the bucket plus work done on the rope also, because the rope is having a certain length, but rope is uniformly distributed body, we have to consider only L by 2. Understood? Okay, so whereas mass of the rope is small m, mass of the bucket is capital M. So when you are lifting a bucket upwards, rope if it is having mass, and even bucket is also having a mass. So what is the work done you are going to consider? Work done can be taken as capital M G, total length is L, plus work done on the bucket is nothing but small m G, but in this case it is taken as L by 2. L by 2 लेंगे, half of the length लेंगे यहाँ पर. Okay, so this is said to be work done in lifting the bucket upwards by a man. Okay, so is how much? क्या क्या common करेंगे यहाँ पर? Capital M plus small m by 2 is equal to GL. Okay, so capital M plus m by 2 होगा, GL is going to be common. Okay, next, massless rope. Okay, massless rope means there is a rope which is having very small mass or negligible mass, means you consider m is equal to 0. Small m is 0 because massless rope you are considering, small m will become 0. Then what is the new formula here? नया formula क्या होगा यहाँ पर? So capital M is there, this part is going to be 0 and this is taken as mgl. Okay, and this is going to be positive force because work done by man ऊपर की तरफ खींच रहा ना, and even displacement is also upwards. So theta is going to be 0 degrees, it is going to be less than 90, it is a positive work done. Next, work done on the ladder. Ladder मतलब सीढ़ी जो नीचे रखी थी उसको उठा के दीवार पे लगा दिए. Okay, there is a ladder which was lying on the ground it has been lifted up and we are placing on the wall so that we can move upwards. ऊपर चढ़ने के लिए सीढ़ी दीवार पे रख दिए. तो how much work you have done? यहाँ पर भी this is a ladder. ये जो है ना सीढ़ी. So you are lifting the ladder from bottom to the top to a height h, and this is a uniformly distributed body. I am taking half of the length, not the total length of the ladder. So here, work done in lifting the ladder is how much? Mass of the ladder, gravity into h. This height you are considering here, okay? And how will you find out that height? You just write sine theta is equal to h by L by 2, okay? H by L by 2. So therefore, h is equal to L by 2 sine theta, okay? So you are working on the man is lifting upwards, okay? So work done by man is positive always. Work done by man on the ladder is upwards, positive. So work done will become minus mgh. Sorry, plus mgh means you write L by 2 into sine theta. This is going to be your answer. This is going to be a formula for lifting a ladder. Next, okay, there was a chain which was hanging. A chain jo hai na, it was hanging. What I am doing now? I am lifting the 50% part of the chain. I am lifting it upwards and holding it on the hook. एक chain hang कर रहा था, इसके आधे chain को हम ऊपर लगा के 50% of the chain we are lifting and holding it like that. तो ये जो लंबा chain था, then what is the work done by you? Work done by man is mass of the chain hanging g into height of the hanging chain. Okay, mass of the hanging chain is m by 2 and height of the hanging chain is L by 2. So therefore, work done by man is how much? M by 2 g, and height of the hanging chain is L by 2. Therefore, work done by man is minus mgl by 4. Whereas work done by gravity, plus man is moving upwards, so work done by man is always positive. Work done by gravity, because you are lifting the chain against the gravity, ये होगा minus mgl by, okay. Now you just here, work done by gravitational force on an inclined plane. तो यहाँ पर क्या हो गया? Inclined plane हम ले रहे. We are taking an inclined plane, okay. तो यहाँ पर अगर हम inclined plane ले रहे, तो what is the work done by an inclined plane? So work done by gravity, okay. नीचे की तरफ force काम करेगा, force due to gravity, and length of the slope is taken as small l, so we will take, okay. It is also positive because it is moving towards the gravity. ये नीचे की तरफ ही आ रहा ना, okay. Now what is the gravitational force in this direction? This is going to be mg sin theta. क्यों mg sin theta? Because downwards is mg, इस direction में normal reaction. This is called as mg cos theta and this is called as mg sin theta. ठीक है? तो क्या काम कर रहा है यहाँ पर? Force due to gravity is mfg, और ये वैल्यू fg का वैल्यू क्या है? mg sin theta into L. Therefore, work done by gravitational force is mgl into sin theta. Okay. Now, work done by horizontal force. यहाँ पर horizontal force है. Okay. So this is an inclined plane. We are applying some horizontal force. मगर ये length, displacement is taken as length of the inclined plane. हमेशा length of the inclined plane is taken as small l. Okay. So therefore, work done by force, horizontal force, is how much? F cos theta into L. Therefore, work done by horizontal force is taken as FL cos theta. ठीक है? That's it. See here. This is a U-shaped tube in which water levels are up to here. Okay, water level दो भी बराबर थे. Okay, so what you are doing? You are blowing an air. Okay, so when you blow air, actually, what was the? अगर खामोश है, तो this is going to be the level of the water in both the cases. This is the level of the water. But when you blow the air, this part will go down, that part will move upwards, and this is moving up and down. Okay, this is going to move up and down like this. But what is an equilibrium position? This is the actual level of the water. But this level, when it comes down, this level moves up. When this comes down, this is moving upwards. So actually, how much height it is going to raise? Let us take this height as x. Okay, or you can take it as h here. That means AC is equal to h here. Okay. So really, how much is raised? Either or either. And what is the mass of the liquid here? ml is the mass of the liquid which is lifting upwards. And either sides, either या उधर, थोड़ा lift होगा mass of the liquid. Okay. Into g into height h. Height h मालूम करना है, तो how will you find out height h here? This total height is h1. This total height is h2. h1 minus h2. Okay. h1 minus h2 will give you total this much length, and this is half of that one. Okay. h1, h is nothing but h1 minus h2 divided by 2. अच्छी तरह से देख लो. Okay. h is nothing but this much value. Okay. h is nothing but this much value. This is h1. This value is h2. Okay. And h is half of AB, because AC is nothing but it is half of AB. Okay. AB का आधा AC हो गया और AC आके h है. अगर h होना है तो this total height of the liquid is this much. When it goes down, this is height h2, and ये दोनों का आधा h हो गया. Okay. So this is taken as h here. Okay. Next thing is mass of the liquid is nothing but volume into density. Volume is nothing but area into h. Volume का मतलब area into height into density. So therefore W. So mass of the liquid. So weight is equal to mass of the liquid, area into height into density. और ये क्या है यहाँ पर? Density. mass का मतलब mass के प्लेस में डाल दिया और क्या बच गया? G into h again. Okay. So volume of a liquid is how much? So this part of the liquid which has been lifted away, I will take that part separately. How much part of the liquid is taken away? Okay, so this much part of the liquid is lifted upward. ये जो part है ना, ये H part का liquid है, this is H. So what is the mass here? Mass is nothing but, इसका volume क्या है? इसका area of cross section ये है, ये area into length is nothing but height here. Area, and this is said to be the volume of that part. Okay, volume is equal to area into height into density. Okay, area mass का मतलब area into height into density. So mass of the liquid is taken as area into height into density. यहाँ लिख दिया, G लिख दिया, H लिख दिया. So what is the work done here? Rho G into H square. Okay, A rho G into H square. So W work done is nothing but A rho G. H square means H1 minus H2 whole square divided by 4. Okay. So ये हो गया इसका फॉर्मूला, फाइनल फॉर्मूला. ओके, और इसको थोड़ा सिंप्लीफाई करके और भी लिख सकते हैं इसको कैसे, GH1 minus H2 whole square. Okay, this is the work done. This is the basics. Next is here. Work done in compressing the gas present in the cylinder. This is a cylinder here. This is a cylinder in which a gas is present. And if, for example, the total distance compression is x. इसमें से हम क्या करेंगे, थोड़ा सा compression ले लेंगे, इतना यहाँ तक का compression ले लेंगे, थोड़ा सा compression dx. If you compress from here to here, इतना अगर compress कर रहे हैं, इतना थोड़ा सा part. So dw is nothing but force into dx part. छोटा सा work, छोटा सा part. And you know pressure is nothing but force by area. Force is nothing but pressure into area. Therefore हम क्या करेंगे अभी? We write dw is equal to force area into dx को separate कर देंगे. Work done by the piston. Now work done on rough surface. Okay, अगर inclined plane अगर rough हो तो क्या होता? क्या क्या चीजें होंगे? Friction which is nothing but mu into n. Okay, so what is this? This is n. This is mg. Exactly opposite to that, mg cos theta, mg sin theta, mg cos theta. Okay, and you know that n is equal to mg cos theta. Okay, and what is f here? F is nothing but mu into n. F is nothing but mu into n. इसका मतलब क्या हो रहा? What is the formula for f? This implies that f is equal to mu into mg cos theta. Okay, so here mg sin theta is acting, friction is acting. Then also it is having acceleration downwards. This body is sliding downwards. ये body जो नीचे की तरफ slide करेगा, इसका मतलब क्या हो गया? Resultant force. यहाँ पर क्या करेंगे? Resultant force is also acting downwards. Acceleration or resultant. So what is the resultant force here? If you common out mg sin theta minus mu k cos theta, then what is the work done is nothing but resultant force into displacement. So because length of the slope, displacement is taken as length of the slope always L here. Okay. So therefore work done by the resultant force क्या होगा यहाँ पर? ये पूरा डाल देंगे mg, L भी डाल देंगे, उसी के बारे में डिस्कस करेंगे. We shall discuss about a kinetic energy. So let us consider one ball and that is resting on the ground. One ball we are taking is having initial velocity u, which is at rest. This is having final velocity v. So it has traveled a displacement yes here. Okay. तो यहाँ से यहाँ तक ball जाएगा. क्यों जाएगा? Because we are kicking a ball by applying sudden force. There is a displacement in the ball. So what will you do now? Kinetic energy or work done, both are same. Work done is nothing but force into displacement. This is the mass of the ball. Okay. So what are you going to do now? क्या करेंगे आप लोग? Therefore kinetic energy is nothing but here also work or energy both are same. And you all know v square minus u square is equal to 2as. Initial velocity of the ball is 0, so this part goes. Acceleration is nothing but v square by 2s. Acceleration is nothing but v square by 2s. So therefore so what are the things going to be cancelled? यहाँ पर क्या क्या चीजें? So therefore finally kinetic energy का formula होगा half m v square. ठीक है? This is called as kinetic energy formula. Next, what is the relation between kinetic energy and momentum? Very important. Many problems are coming on these two relations. कितने problems मालूम? Series of 6-7 problems है m v square. ठीक है? ये kinetic energy का formula है. हम क्या करेंगे? Momentum का formula मालूम है, mass into velocity हो गया. So what is the kinetic energy on m square? V square is nothing but p square by 2m. Okay? This is going to be your final formula. ये हो गया आपका final formula. अब इसको क्या लिख सकते हैं? We can write this as 2m इस तरफ भेज दो, p square root of 2mk. Like this also can write. Therefore, momentum is directly proportional to root k, okay, and k is directly proportional to p square. बहुत सारे problems आ रहे हैं. Many applications are coming on this relation. Next, और एक क्या concept है? The next concept is work energy theorem. The next concept is work energy theorem. ये आज पूरा जो भी पढ़ा रहा हूँ मैं, it's the basics, completely basics. Let us take a ground and let us take one ball. Let us take a ball here, okay. So इस मतलब क्या करेंगे हम लोग? Ball is already having initial velocity, okay. Ball जो है ना, football already move कर रहा था. Already it was moving, it was not at rest. मैं उसको जो बॉल मूव हो रहा है उसको और जोर से, सो v स्क्वायर माइनस u स्क्वायर इज इक्वल टू 2as. ओके, एंड ये इज नथिंग बट क्या है? v स्क्वायर माइनस u स्क्वायर बाय 2s. एक्सेलरेशन आ गया और हमारा बेसिक फॉर्मूला क्या बोल रहा है जी? u इज इक्वल टू फोर्स इनटू डिस्प्लेसमेंट. काइनेटिक एनर्जी इज नथिंग बट वर्क डन इज नथिंग बट फोर्स इनटू डिस्प्लेसमेंट. देयरफॉर काइनेटिक एनर्जी इज नथिंग बट m, ये छोटा कर देंगे ना. काइनेटिक एनर्जी इज इक्वल टू m, ये a के प्लेसमेंट डाल क्या डालेंगे? v स्क्वायर माइनस u स्क्वायर बाय 2s. वही फॉर्मूला. And one more s is here. S gets cancelled. Therefore kinetic energy क्या होगा? Half V square. So work done is nothing but kinetic energy final minus kinetic energy initial. So this is your final formula. ये हो गया आपका final formula. Work energy theorem का मतलब ये है. We shall discuss about conservation of energy. Okay. So what is the meaning of conservation of energy? Energy can neither be created nor be destroyed. That is called as conservation of energy. So let us take a ball here and a ball here. This is height h. This is on the ground. So here potential energy is nothing but mgh. You are throwing a ball upward with an initial velocity u. यहाँ पर height is equal to 0. Therefore potential energy is going to be how much? 0. Okay. When you throw a body upwards, potential energy is going. So what is the kinetic energy at A is taken as half m u square. So therefore total energy at A क्या हो रहा? Potential energy at A plus kinetic energy at A. So therefore total energy at A is going to be potential energy at A is how much? 0 plus kinetic energy is how much? Half m u square. Because you are throwing a body upward with initial velocity u. Okay. Now this is all at A. Now we shall discuss what is happening at B. Okay. So B के पास क्या होगा यहाँ पर देख लो. Here the body is going to stop here. Body is going to stop here at the highest point. इसका मतलब kinetic energy is going to be 0. What is the potential energy? Potential energy. But हमको क्या करना है? V square minus u square is equal to minus 2gh. Okay. Final velocity is 0 here. Final velocity is 0. Minus gets cancelled. Final velocity is 0. Minus gets cancelled. What is the height formula we are getting? H is equal to u square by 2g. So h is equal to u square by 2g. Okay. तो यहाँ पर क्या करेंगे हम लोग? हम डालेंगे mgh. h के प्लेस में क्या डालेंगे? u square. So what is total energy at B? Potential energy at B plus kinetic energy at B. So potential energy at B is how much? Half m u square. Kinetic energy is going to be 0. Therefore total energy at B is how much? This is called as conservation of energy. Let me stop the class today. So tomorrow we shall discuss about the applications of this work energy. Okay. Thank you.